Okay, so let's continue our multi-threading
Mhm.
concept.
Sure.
An example. So in study class, we have understand how we can communicate two thread between to the each other. Our
Mhm.
example was just taken like a producer and consumer. How
Mhm.
producers are communicate talk to the another thread like consumer threads. So to
Mhm.
discuss the case here, we are using the some shared object. This is the shared
Mhm.
object, and these producers are going to write data something and say, "Hey, I am going to the wait. I am
Mhm.
going to the wait." Okay, let's consumer thread get a chance and go read this value. First, I am able to read, and then say, "Hey, I am notifying," so that someone waiting for this common resources they can awake, right? So whenever
Mhm.
say, "Hey, I'm notifying it," this waiting thread awake, and again they are going to write the some data here, and after that again
Right.
they go to wait, so that someone can again read. In this way, say we have understand how wait and notify this mechanism where one threads are communicate to another threads.
Mhm.
Here is the two this is the common resources. So our ensure that at a time only one thread can read or write operation perform here, because
Mhm.
until data is not right, there is no any make sense to read data, right? If this
Mhm.
thread get a chance and going to read data and no data is written here, so that means this thread must be wait somewhere, right?
You're right.
Where. So if this thread get a chance and go run and write some data, and then they can read.
You're right.
So good option here, we have to apply some kind of mechanism. Hey, only one thread at a time can access this
Mhm.
object
Mhm.
using this. So yesterday we understand the concept of your synchronization block or synchronization method. This
Mhm.
help us to ensure that particular my resources, a particular my method, any one thread at a time can access.
Mhm.
Right? So yesterday we cover this kind of tools. What is the synchronization? How to use and how can use this wait and notify. This is
Mhm.
the one primitive level of uh, tools or uh, API developer have can use to thread communication. So
Mhm.
for thread communication, we use tool. We use like
Mhm.
for getting a lock, for getting a lock, we can use a synchronize keyword,
Mhm.
synchronized, and similarly for waiting, we can use the wait method, and similarly for in for informing or for updating or informing, we use the
Mhm.
notify method. Okay? Super. So till now this study example understand. So the last couple last to last class we say this is a one of way where thread locking can be happen. And last class also we discussed we have another way where let's today we are going to example, we are not going to use a synchronized
Mhm.
keyword, we have option also lock as interface.
Mhm.
Lock as an interface. So today, let's try to understand the same problem here. Whatever the couple of days we are going to understand producer and consumer problem, how we can use this lock interface and how we can use the wait and how we can notify using the different way.
Mhm.
Right? So
Mhm.
our question problem is the same as the last class. we have a one thread name is the producer. Producer is going to producing some data. Let's they produce the message A, okay? And I
Mm-hmm.
say, hey, another thread come and try to consume this message, read this message. A, I'm read the message A. Again, they are trying to read, but there is a no new message, right? So they have to wait because there is no new message written by the producer.
Mm-hmm.
The already written data I already consume here, right? And
Mm-hmm.
after consume, I am sure ki, hey, this data should be clean, right?
Mm-hmm.
So that ki, there is a no data read for the next time, right? So if this message a buffer are the empty, this thread are going to the wait until someone not writing data here, right?
Right.
Let's this thread again get a chance and going to write some data here, some write data here, and hey, I'm going to wait. Someone can come and read the message. Hey, this thread again go, hey, now I have received my message. I'm going to read the next message, right?
Mm-hmm.
In this way, we are going to write the code to understand using this lock interface, right?
Mm-hmm.
Same problem, we started discuss using the synchronized keyword wait and notify. So for similar kind of a getting object lock, we have a multiple mechanisms like a synchronized keyword, like a lock interface, and some more couple of example, couple of way. In coming classes, we have to discuss one of them maybe semaphore concept, and another is the concept existing library already which implemented the synchronization locking or semaphore concept. Just you have is a simple implemented internally class. Now this just you can this a class specific library Java library that
Mm-hmm.
help all the things internally, right? So
Mm-hmm.
later part we can also go to the specific library available to solve this problem. But first, before going to using the existing library, we have to understand how, if I'm not using the library, how we can manually com- try
Mm-hmm.
to communicate thread between, right?
Mm-hmm.
Till now, any confusion about what we are going to solve
No, no.
is clear.
Yeah.
Yeah.
So, as usual, let's first I am going to what are the steps? First, I am going to write this buffer part, right?
Mm-hmm.
Where we have a buffer and the place the variable where you can write some data, and one is the method for put writing data, one is the method to read data, right? So that ki
Right.
this thread going to read operation, this thread going to write operation, right? Producer
Right.
always write data and consumer always read data.
Right.
So we are going to write, and once this our done activities, then I am going to create one thread producer, one thread consumer, and just
Mm-hmm.
start. And let's both are working as per our expectation or not.
Right.
As let's example, we have write a class. Let's see buffer,
Mm-hmm.
okay? Buffer class, and buffer class have a let's study use the list. So let's use the same. Private we have a maybe list
Mm-hmm.
of integer, a list of let's get mm, message is any message.
Mm-hmm.
Instead of integer, let's say message. Okay? Let's have character. Okay, whatever the character, and here say this is the data to you can say new list. Okay,
Mm-hmm.
here this is the data part where we can write data A and B and C, and someone can go read data, because whenever you are writing any variable, any value, you need a data holder, maybe data collection
Mm-hmm.
framework or array or any simple variable, right? And these have a at least a two method. One is the write data and the maybe read message and write message. The one method would
Mm-hmm.
be public void write message, right?
Right.
Write message, write message, and
Correct.
he just receive maybe one message. It's a message will be let's give a string some message, okay?
Right. Okay.
Message. Okay, and here give this message, and here so let's give string, okay?
Mm-hmm.
I can write message one, message two, message, okay?
Sure.
One method would be somehow someone read message, okay? say just say read message. Read message. Read message. They're not passing anything. Just want to read message. So here they are going to write in this message here message dot add. Okay, whatever the message you want, I am to add the message, right? Write means just we are going to write data in the this message. Read means just I am going to read from data here, right? So here say hey message dot, and after read I want to clean. So okay, already read. So I started with this is one method, remove and say they return the value and they remove the data. This message already my read it. Okay, read. So this is the list type of a method remove. Remove means they return the value and after that this is the list, and this list type I write message A. Okay, this is message A. They write message A, and if I going to read message A, I read the message A, and after that I have to clean them, right? So that
Right.
next message can be written. So I am saying the not get method. I am say remove method. Remove method do both work. You can use the remove or internally one say key get and remove two method call. Okay. Here I am able to just print out hey out message read message read message plus instead of read this to do message. Here say key this is my message. Message message read by just give the thread name. Which threads are read, right? Thread dot current thread dot get name. This is the way you can figure out key who are executing this line. So till now there is no confusion. You can just create one buffer. They have a two operation. One is the write message, one is the read message. Right? You can say produce message or consume message. Both are the same thing here. You can say write or read or produce or consume. Both are the same thing. Produce, produce message. This is the consume method.
Right.
Both are the same meaning. Consume method, right?
Right.
Correct. So as of now, it's okay. If let's I say ki this method is used by the thread, another thread, producer thread. This method is used by the or consumer thread. So what happens? Let's say consumer thread come first and try to read value. If there is no data, then what? Consumer we have to something wait, right? If no data, what if let's this thread come and in our buffer data there is no data. So what I am going to read here, right? Nothing. Then our responsibility we have to check until we have not some data. Please wait, right? So here I have to check. Hey, before reading, you have to check your data dot is empty. If this is empty, okay, then what you do? We have to wait. Okay, somehow we have to wait because we cannot go read data until, right? It's clear.
Right.
This is the one check. So we are going to put something. If it's empty, we have to somehow wait. I am going to think how to wait, right?
Sure.
I'm just explain later. But here we have to our consumer thread must be wait until data is not summoned written, right? And second scenario here as well as if this is my producer thread come and going to produce message. Let's say they are getting a chance and producing a message. They are just written a message A, okay? And next time this thread again get a chance. Again they are going to not write message because already have they written message. Someone not consume them. If already have a message here, that means this producer thread must going to the wait, right? Already have this message written, but someone till now not consume. What say, hey, here apply check similarly here. While data dot length or size, this is the size method. If equal to 1, that means already data available here. You have to wait, right? So that key until someone cannot read, why you are going to pushing another new data, right?
Mm-hmm.
Already you have a produce one message and someone not read it till now.
Mm-hmm.
It is clear.
Right, right.
So what does the while condition does?
While condition, I'm going to think here. While condition say producers are not going to produce new message until someone not read, right? Size
Mm-hmm.
one means कि already your buffer you have already written for, if let's this thread get a first time chance, so this size should be 0 because no message, right? So this
Mm-hmm.
0 could not go inside loop. They come here and add the message. Let's new message added 1, right?
Mm-hmm.
Let's keep after this thread till now not get a chance to run, right? Then again this thread get a chance to run, then again come, and again they are going to the right message. So I am saying, hey, first check, already you have written some message here and someone not consumed. Then you have to
Mm-hmm.
wait here, right? So
Oh,
this
okay,
is
okay.
the size one means say, hi, already previously I written one message, till now someone not consumed, right? So I am going to wait. I am waiting, consumer thread come and read the message and say, I have read the message and I clean up them, right?
Mm-hmm.
So until this thread is this list have some data, they are going to the wait.
It's
Okay,
it's
Yeah,
is it clear?
yeah.
yeah.
And question is that if these are the uh, multiple, you can say multi-threading,
Mm-hmm.
so might be chance these threads are continuously call or these threads are continuously come. Notice these are two, producer and consumer. Our objective at a time this thread run or this thread run, right? Both cannot run at the same time, right?
Right.
Producer is running, this consumer must be wait. If consumer
Mm-hmm.
running, producer must
Mm-hmm.
wait.
Mm-hmm.
We have to somehow, this is the my one kind of mutual understanding lock. Hey,
Mm-hmm.
this is the my kind of object, we need some kind of locking, so that if one threads are accessing my resources, other one wait. If other one accessing, next one wait, right? So that
Right.
means we already know for this we have a concept of lock manage mechanism. A lock
Right.
mechanism can be implemented by multiple way, right?
Uh-huh.
Yesterday we understand with the synchronized keywords. Today we are going to understand the lock interface, then semaphore, then blocking queue, and lots of things, right?
Uh-huh.
So let's understand how we can use the lock interface.
Uh-huh.
Okay. So here say, hey, we have a one private lock interface. Lock. Lock is the interface, just say K lock. Lock equal to new reintent lock.
Uh-huh.
Last class say कि whenever lock is a interface, if lock is a interface, you cannot create the object of lock, then we can say implementation class. This is a reentrant implementation class. They have implemented this here. Uh, what is lock interface, right?
Uh-huh.
This is the interface implemented by the lock interface. So we are going
Uh-huh.
to reentrant lock. So now we have a lock, it, and we have to now lock object clear. So
Uh-huh.
as usual say, whenever we are going to producer, we are ensure only one can get. So here say, hey, producer dot lock means here first someone producer get lock. If get lock, then do something. Once your work done, then we say,
Uh-huh.
hey, lock dot unlock, right?
Uh-huh.
Means here first I am going to take the lock. If lock done, I am doing these activities, and if I am activity done, I say unlock, right?
Right.
Similarly, if consumer is come here, if consumer trying to say, consumer say, hey, first I am trying to get lock. If I
Uh-huh.
get lock, then I am going to do this activity, and after that I am say, ki, hey lock, I am going to unlock.
Uh-huh.
Till now is clear. In this way,
Uh-huh.
we are ensuring that these two producer and consumers are not the same time going to run. Why?
Uh-huh.
Because I say, ki, hey, first you are going to do this activity, you have to acquire lock. If you are
That's
getting
it.
lock, then we can do.
That's right.
So this is the beauty of your, whenever we have a lock object and someone say get lock. If one
Uh-huh.
thread get lock of that
Uh-huh.
and other thread. Let's this thread get a chance to run, and this thread say, hey, get a lock. Already this lock is used by this thread, producer thread. Then other thread must be going to the wait automatically, right? So this is the way lock is the method which ensure that this code executed by someone or this code. Both code are not going to executed same time by multiple threads. It's clear?
So
Yes.
if we lock it,
Hmm.
what is the difference between synchronized?
Just I'm trying to different way of implementation, right?
Okay, different way. Okay, I see.
Right. Okay. And lock have some additional benefit we'll discuss, right?
Right.
Whatever they started to is the same thing we are doing to here, but with a different enhancement version of Java, right?
Hmm.
And we have some additional benefit we can here lock interface help us give, right?
Yeah.
Great. And till now, it's any doubt, any confusion?
No.
And now problem, how we are going to the wait, right? Here. Because our condition, let's get this get a lock, but there is there already one data. Still they have to wait something. So how I'm going to wait on this lock, right?
Right.
So lock have a one method like here lock dot condition. Okay, lock dot okay, let me final. Okay, and here say this lock dot why are not this? Let me here write log dot new. Okay. Okay. This is the one kind of additional things you have here. That's the private final. So now this lock have a condition. On which condition this condition have a wait method and signal method. This is the condition. This condition have a wait method for waiting, and they have also signal method to await have a and similarly signal method as signal all.
Right.
Notice in the case of our synchronization, we have used the method wait and notify. Similarly, in case of lock interface, we have to use this method signal or not signal for notification and await for waiting, right? So here we have a wait. The condition here say hey condition dot await. Okay. Now you are awaiting. Okay. Similarly, what once you're done, you can say, hey, I'm once data done, someone waiting, you can say, hey, condition signal all. Just I'm going to notify, right? Once I done my data written done, after that I'm giving the notification. Hey, I'm giving the signal to the all, whoever is waiting for me. Similarly here, if we have some condition, then we can say, hey, maybe good option you can give the two lock, one for the full lock, one for the your can say empty lock. Name should be here, right? So let's look condition dot again await, and we are awaiting. And once your activity done, after that some say condition dot the signal on. So in this way, you are trying to say, hey, if this thread going to run, okay, they are throwing this method. Notice await method throw interrupted exception. So our compiler complain me, hey, you have to write you can write here try catch or just throw exception, whatever option. So maybe you want to try catch, so you can write maybe here look like either try catch or add to the exception. Both options we have, right? So in this way, you are throwing exception. So in this way, our this code is written. This is the one my buffer class. They have a data place, and here we have mechanism produce message and consume message. Now, what the next objective? I am going to create the one producer thread that calling this method, and one consumer thread that got calling this method, and check as per expectation, the both threads are communicating to each other or not, right?
Mm-hmm.
Till now, any confusion, any doubt?
No, it's
So
better.
condition is the interface.
Yes, condition is also interface.
Hmm. So when you
And
type condition equal to what do you
means
call like?
I'm getting from lock. This is the lock object. Now from this lock, I want to go on condition because
Okay,
I am
okay.
going to wait, right? So this lock have a method get new condition, right? This is the new
New
method
condition is coming from lock.
lock. Yes. Notice this is lock dot condition, right?
Right,
Because
right.
I have
Okay.
this is the I'm getting the object lock, and for the I need a condition, right?
Hmm.
It's good till now.
Yeah, yeah.
Yeah.
So let's start the threading till now there is no threading concept. Just assuming I now whenever I am going to run this program, that time I am going to introduce, hey, this code run by my one thread and this code run by my another thread, right? It's clear. So now I am going to start the threading part.
Mm-hmm.
Right.
Okay, so let's do here. So how we can do threads? Simply we have multiple approach, right? So let's do the runnable interface directly. Not I'm going
Right.
to write any new class because we have option thread can written from the like last example you can use thread using the class implement runnable. Now I'm going
Mm-hmm.
to use a simple lambda function because directly we can pass, right? Here
Right.
say this is my runnable producer thread producer producer and here say lambda function, right?
Mm-hmm.
Right.
And simply say I am going to this is the producer thread. They need a message. So here we have to write something code here, right?
Mm-hmm.
And let's generate some message here. Message one,
Mm-hmm.
message two, something, right? Message
Mm-hmm.
A, message B, message C, something, right? So
Okay.
here how to generate message? Let's start from character. Oh no. Here I am going to let's create a, a class okay, class producer because here I have to producer implement enable interface, right? And here
Mm-hmm.
say they need to override run method.
Mm-hmm.
Okay. Similarly, one my consumer. This is a true thread, right?
Right.
This is the consumer. Okay.
Mm-hmm.
Now, how can I start a thread? Only know to
Mm-hmm.
just a new thread class. Okay. Thread
Mm-hmm.
class start, right? This is the basic way to start. I want a two thread start. This is the two thread started. But so what this thread do? Hey, this thread do. This is the producer thread. This is the consumer thread. So here I have to pass this producer threads and consumer threads.
Yeah.
So this is
Producer.
a new producer thread, right?
Yeah.
Mm-hmm.
And here say this is the consumer thread. So here say hey, a new consumer thread, right?
Mm-hmm.
Yeah.
And let's say I give the name as a this is the name of the thread. Thread name producer thread.
Mm-hmm.
Producer
So,
producer thread. And here say this is the name of this thread. Second parameter is the your name of the thread. Consumer. Not writing this by default. Our JVM give the thread 0, thread 1 name, right?
mm-hmm.
Good. Now, till now, this is the way you can create two threads. One is the producer. Okay.
Mm-hmm.
Okay. Producer thread and one is the consumer thread. So threading is this is the simple way. You can create new thread and start. Another thread
Mm-hmm.
start. Here producer have a here what producer going to do? Here consumer what are doing to. So here producer is responsible to call this method, right? Produce method, right?
Right.
And consumer thread responsible to call the consume method, right?
Right.
That means this buffer object they need access by both, right?
Mhm.
Here I am going to create, hey, this is my why I am here. Notice this is my one thread created producer here, one thread consumer. Now it's clear. Here producer threads, here consumer thread. Now
Mhm.
both need to access this buffer, right?
Right.
They need a buffer to call the produce method. They need a consume method, right? So
Right.
this we are going to create this object and pass, hey, you access this and you access this side, right?
Mhm.
So here say,
Makes
hey,
sense.
this is my buffer equal to new buffer, right?
Mhm.
And here say this is the buffer, take your buffer, right? As a
Mhm.
constructor you can pass. So inside the we need a constructor, right, to receive the
Mhm.
buffer. Add the
Mhm.
constructor, okay, and
Right.
similarly add more constructor here, both the okay. So in this
Right.
way you can say both. Uh, Now this run method is this variable must be declared on the class level so that this method, run method also access this buffer variable, right?
Mhm.
Start buffer equal to buffer, right?
Mhm.
Similarly here also you can do. So now this run method, now they are going to this run method, they are going to the call produce method, okay, and this consumer are going to the call the producer dot buffer dot consume method, right?
Mhm. Mhm.
These threads are going to the consume method. This thread going to the call the produce method. So
Mhm.
produce method they need a message, which message they want to produce, right?
Right.
So here we have to generate some message. Let's maybe thing
Mhm.
message. Okay.
So
Mhm.
producer message is the method name.
Huh.
And that.
Sir is calling the produce method, right?
Yeah, yeah.
Notice
Yeah.
the buffer. In this buffer, we have written two methods. One put to the write message, one is the read message, right?
Mhm.
So this producer threads is responsibility to writing the call the produce method. So that here message one produces, right?
Right.
And consumer thread responsible to call the consume method, right?
Mhm.
So
Mhm.
here producer threads are going to call the produce method and consumer thread going to call consume method.
Right.
So it's clear.
It
Yeah.
is.
And the
And
list type was string or character.
initially I decide ki list string, right na here or objective.
I
Okay.
think it's called yeah, string. Okay.
So here you can say if you're going to call this produce method, they are expecting give me the message. Message is string, right? So here
Mhm.
you
Right.
have to create some message. Okay. Message let's equal to message, okay,
Mhm.
and you can pass the message, okay.
Right.
This is the one way, and this method throw because this method throw your interrupted exception, then you have to handle try catch, right?
Right. Right.
So till now, okay, what you retain, you have written one message one, and
Mhm.
producer produce them and consumer consume them.
Mhm.
It's clear.
It's
Yeah.
clear.
So let's test them, okay, and here say let's just s out main done, okay, completed
Mhm.
and completed, okay,
Mhm.
main started.
Mhm.
Now after 5 class, it feels lot comfortable now.
Due to that, I
Now
am writing
Definitely.
multiple examples so that you look same example so that you come get comfortable, right?
I'm
Mhm.
getting comfortable, lot comfortable then.
So here clear, I am creating one your buffered object, shared object, and passing to both threads so that both threads can start work. Our objective,
Mhm.
initially objective, why I'm going to threading because this is my actually two methods. This method, producer method, producing data, consumer method, consuming
Mhm.
data. I don't want this method, this code should be run in a parallel thread, separate thread. This should be
Mhm.
run the separate thread. So I say, hey thread, you can call this method, another thread call this method, right?
Mhm.
So let's run and test the output, right?
Right.
Notice message is consumed by the message one. Okay, and let us write something. Producer produce message something, right? One message also
Mm.
come from. Similarly, message here say this is here. Here say
Mhm.
message uh, produced.
Mm.
Okay, pro message message. This is produced by
Mhm.
produced by produced by thread name, and this
Mhm.
is the message consumed. Message consumed. Okay, comma. Okay. Here, let's give the message name like message one or message two. Any in the producer are going to just produce uh, where the my message producer send message one. Producer
Mhm. Mhm.
producer send message message one. Okay, as of now,
Mhm.
let's
Mhm.
run. So notice here, uh,
Mhm.
producer send message one by produced by producer thread and same message is received by the consumer, right?
Right.
So here, this is the one example. I'm just writing one and one receiving, right? As
Mhm.
a
Mhm. Mhm.
why not our producer producing some 10 messages or 100 messages are
Mhm.
infinite, right?
Mhm.
And consumer can always be consuming, right? So
Mhm.
here
Yes.
I'm just writing only. Why not call this code in a loop, right? Let's here say loop uh,
Mhm.
stream dot let's range let's give one to let's give they want 10 messages, right?
Mhm.
And that for each let's each number, okay, and we have to
Mhm.
do right here, and this code I written in the this is the code, I write inside this loop, right? So
Mhm.
here instead of one just say plus n, okay,
Mhm.
first time one then two then three then okay,
Mhm.
okay, message one message two message three, right? This way we generate
Mhm.
the different message, right? Here message one then
Right.
message two, then message three, they are sending the multiple message. If they are
Mhm.
sending 10 messages, similarly, our consumer can consume 10 message as well as,
Mhm.
right? Our
Mhm.
consumer code, this is also could be like consume 10 messages. So here this code should be inside your loop,
Mhm.
right? Yes, they are
Right.
going to consume 10 messages, right?
Mhm.
So depend upon the use case, you can generate the scenario. Let's run.
Mhm. Mhm.
Now they are producing and consumer consuming. So let's add some delay so that we are getting some delay output, right? So
Mhm.
here, let's producer send data. After this, let's wait some. Uh, After sending data, they can say thread sleep dot just sleep for duration of 2 seconds, right?
Mhm.
And let's after each 2 second, producer produce data and consumer consuming data, right? So
Right.
producer produce consumer consume. Producer produce
Mhm.
consumer consume, right? Producer produce
Mhm.
consumer consume. Same message produce consume produce consume, right?
Right.
The different thread name. So in this way, we can implement producer consumer problem using the lock interface and the conditions, right? So notice
Mhm.
here, I am producing messaging using the lock interface and
Mhm.
unlock.
Mhm.
So till now, any confusion, any doubt,
Mm. Yes, yes, good. Yeah.
right? Maybe
Yeah.
here it can make a delay as well as in the consumer part as well as.
Mhm.
Okay. So
Mhm.
right. So both are some delay. Just this delay for just our looking output. Producer produce message, consumer come consume. Producer produce, consumer consume. Producer produce, consumer consume. Right? This is the way message produce and consume. Produce by producer, thread, consumer consume. Producer produce. So what the here doing? This is our thread producer, and this is our thread consumer. Right? Producers are just first they want to produce 1 to 10 messages. The first they produce message 1 here. Message 1 produce, and consumer come just read message 1 and clean them, right? Then producer produce second message. Second message read here, read second message, clean them. Producer produce third message, third read them and clean them. The consumer is doing 2 work, reading message and cleaning up from here. Right? So in this way, generally, this both threads are communicating to each other by a shared object. And in a shared object, like here, our buffer is the shared object. Buffered object is shared by the both thread. Okay.
Now, can I see the buffer object again here?
Yeah,
Right?
this is buffer object.
Okay. Is it possible, like we did some work on producer here and also consumer, right?
Yeah, this is the
Inside buffer.
producer. Yeah, yes, producer, and this is the consumer. Yes.
Okay, but can we make we cannot do it. I was thinking like if we can divide this producer and the consumer method inside the producer class.
Yes, you can do.
We
This
can do,
method
right?
you can write separately here inside.
Okay.
That's same, it's not an issue.
Okay.
Our intention is that our thread responsible to just thread my work. They are not generally prefer inside a run method. You don't write any business logic. Run is just used for just invoking. Hey, this is the thread code. Just run in a thread, right?
Right. Got
Whatever
it.
written just should be your business logic method, right? So
Got
just
it.
segregation logically, this is the consumer means they are working on some buffer, right? This is our
Yeah.
data and data there. Here I have a data, so here they are consume. Here I have a data, here so produce, right? You can
Yeah.
do, but the logic, so just general guidelines, always try to put your business logic in separate and run logic in a separate. Run just like your run is the one person which is running the code. Why you are saying, hey person, first you generate the code and then run, right?
Right.
Your responsibility just run code. Which code you want to run? I'm just informing you. This is the code run by producer thread. This is the code run by consumer thread, right?
Okay. Yeah.
Surely the same code you copy and paste in the run method, it work fine. But initially, whenever we are learning program, you can do. But generally, as practice, always say, always write your business logic in separate class. Okay, and you can give the proper name, proper meaning here, right?
So
This
what part is the business logic in this?
This is our business logic, producer method of producer, right here.
Oh, the
Just-
producer. Okay, so this is the business logic.
Yeah, our business logic simple. We are going to produce one message, right? Consumer going to consume message.
Right.
Is clear?
Yeah.
So this is the way. Let's you try. So look the starter code, same thing. Just we are using the synchronized keyword previously. Now I'm not going to use synchronized keyword. I'm just using the lock interface. The first I'm getting the lock of this object, and then producing message, and then just unlock them, right?
Yeah.
But here our business scenario, our thread need to wait as well as if already written some data until not consume, then we have written discontinue. Wait something until
Right.
some not consume data, right?
Right.
Yeah.
Similarly here, if consumer is going to consume data, first need the lock of the subject. They get the lock, I get the lock, and what they check? If there is any message or not. If no message, then I'm going to wait because I have not anything to read, right? So this condition only check your buffer is empty, then you have to wait because you cannot consume data. Here you are trying to get data from the first position. If you know data, then you can get exception, right?
True.
Right.
So this is the way. Until empty, you can wait. If not empty, then come out here and get data and notify that, hey, I read the data. And after that, just say signal to all. If someone waiting on for me, because I have a lock, someone waiting for me, I'm just get notification, hey thread, you awake. Now I'm releasing my lock. Why? Because this buffer is the only one object, right? Buffer have a only one object. That can be used by thread one, means producer and consumer, right? If this thread try to access, first they are requesting give me the lock. If they get a lock, that this is a lock acquired by this thread, and at this thread, someone going to try them, hey, get the lock, they need to wait by default because someone already using them. So lock, this lock ensure that this line ensuring that if this object are used by any other thread and same time another thread come and try to consume message, they are going automatically in waiting stage, because until this is not releasing unlock, you are not going to take lock.
Right.
This is the acquiring lock, this is the releasing lock.
Right.
And why I'm saying here wait or notify, because maybe they are waiting only, maybe after some time they are going to wait. Okay, so wait,
Right.
someone must give the signal, hey, I have done my work, you go and start. So this say, hey, signal all, means whatever the all threads are waiting, just awake and try to get lock, right?
Right.
So these are the similar things are used by the synchronize, similar things used by your lock interface. Similarly, one more concept we are going to understand, the semaphore tomorrow. Here notice this case are I am going to only allow only one thread at a time can read message or write message, right? But some cases, some scenario, sometime I need, let's say at a three thread can go read and write data, might be right, or four thread, depend upon the situation. In real life always we have a limited number of seat, limited number of place, right? Some cases, let's say in the case of a game or anywhere, generally winner or number one position is the only one, right? Maybe 10 teams are participating, number one team become only one, right?
Right.
There are two team become a number one, right?
Right. It could be happening.
Yeah, so depend upon the condition. Sometime I say, hey, this is the my my ticket booking counter, okay? I can create the three booking counter, right? Huge number of people come for taking ticket, right?
Right.
I am going to say, I am going to allow in my booking center room only three people at a time, right? Three people go, one people, two people, and three people, right? So here our case, this is the my one object booking center, and this booking center I have to allow three people can go at time, three people another can wait, right? Next time other next three can go, next time maybe two, one is a free but two still waiting, so I can only allow one, right? So some situation our common resources have a capability, they can need a three kind of controlling. Might be some case we have a booking counter, just we have only one booking counter, right? There is no other booking counter. So in this case, lots of people come here and I say only one can go in the counter, right? They can get ticket again back, then next go. So here synchronization and lock both are just allow only one thread go and access my this common resources, shared resources, right?
Right.
Till now both have understand synchronized and lock. Both are work on the just only one object or only one thread can access your shared resources.
Right.
Okay. So first, whenever we starting question, Riyadh asks you what the difference between the synchronization and the lock interface, right? Both are the same, right? Synchronization since Java 1 and this comes since Java 5, right?
Right.
Question is that whenever you write synchronized block, right? This is a synchronized block, right? And synchronized keyword, right? Here word. And
Yeah.
here I would say lock dot lock and unlock, right? I'm doing here. So here we have this lock object help us to figure out the new threads come to try to access here,
Hmm.
so we have a complete control.
Acha.
I can find out if someone already accessed the resources, then if I'm interested, I can wait or I can go.
Hmm.
In this case, in the here this is the only one object, and let's keep
Right.
one thread come, and they are processing, right?
Right.
Here also one thread come and get the lock and doing processing, right?
Hmm. Hmm. Hmm.
Let's here new thread come, new thread wait, because already someone using, right? New
Right.
threads come, wait. New threads come, wait. New threads were all thread by default come, we are going to wait.
Hmm.
Until what? Until this thread are not release lock. All the threads are waiting until this is not release lock. Okay.
Okay. Acha.
So let's come here scenario. One threads are processing the scenario. Next thread come. Again try to lock. Wait. Again try to lock. Wait. Again try to lock. Wait. Again try to lock. Wait until this not releasing. The same behavior here also. But
Hmm.
additional cab here one person say if I can know if this is used by another threads or not. If someone already used, I'm not going to it, I'm going to back.
Hmm.
Right?
Hmm. Hmm. Hmm.
This
Hmm.
thing not possible here. Here
Hmm.
we
Hmm.
have a method like a try lock.
Hmm. Hmm.
Method name is here try lock.
Hmm.
Whenever
Hmm.
you say try lock, this thread come and check this object is already used by someone. Yes, then my mercy, I'm waiting or go back.
Hmm. Hmm. Hmm.
Or you can say, I can wait only 5 minutes. Till 5 minutes, this code is free, then okay for me. More than
Hmm.
5 minutes, I cannot wait, I go back.
Hmm. Hmm.
So these things we can implement in the try lock, which are previously in synchronization block, we have not any option, right?
Hmm. Hmm.
Correct.
Riyad, is it clear?
Yes.
Here we have some flexibility. Whatever the new thread come here, they have an option. First, they can check the object I want to call, I want to access is already used by any other threads or not. In this previous synchronized block, there is no any option to find out the particular object are used by someone or not. By default, they come and go in the queue because they don't know कि already used or not. Because I'm going to call, just by default internally, JVM know that already used by someone. You just wait. I'm not saying any methods available. Yes, someone wait true false something, right?
Hmm.
But here we have option. Check the particular lock for you available or not. If available, you can do. Not available, you can go. I just we have option now. I want to wait 5 minutes. Someone using. I can wait 5 minutes till 5 minutes. If this lock is released, I'm okay. Else I can go back. So these additional things you can use in the lock interface. So this is known as a fair locking mechanism, right? They have some fairness between the waiting threads. So what will do? Here simply say instead of try dot lock, here we can say lock dot try lock. A try lock type is this method try lock means, and notice they return the boolean value. Okay? So here from boolean you can say ki is locked or not. Okay, is locked. Now we have an option. If true means you can get the lock. False means you are not getting a lock means someone already using. Right? So this have a possible true value. This may be true. True. True means you are getting a lock. You can go and run. You got the lock. Okay. You got the lock and go use them. Okay. This is the object.
Right.
Second case possible false. False. False means you not got the lock and wait to to get lock. Okay. Or go back if you don't want. Okay. Go back if you do not want to wait. Not to wait. Okay. Now we have in case of false, you have two options. I'm
Mhm.
waiting or I can go back.
Mhm.
Similarly, one more have a option here like lock dot try lock, and here I can pass timeout. I can only wait 2 minutes. Okay, 2 minutes. Okay, here say I'm try to wait only 2 minutes. Within the 2 minutes, I can get the lock. I'm okay. I'll say go back. So
अच्छा.
this timeout also have options. So let's say no, I can we are here at least minimum 5 minutes. After 5 minutes, I have not any more time to wait here. I can go, right? Maybe I'll come later, right?
Mhm.
So they have one more important things about the timeout option. In the
Mhm.
synchronized block, there is a no timeout option. There is a no check particular lock is available or not available.
Mhm.
So these are the additional things you can say are have with the try your lock interface.
Mhm.
So now is makes sense something when we
Yeah.
have to lock or unlock, right?
Yeah.
And one of the major uh, things sometime is a problem versus lock versus synchronized is synchronized that if you are writing code synchronized keyword using this way,
Mhm.
whenever you are going to in future, we are going to take a new class where we are going to till now notice we are only creating the here thread that is the operating system thread OS thread. This thread known as a your OS thread operating system threads. This thread concept is not implemented by Java virtual machine. Whenever say dot new thread, that means our JVM just request hey operating system I want to create one threads. So these threads are known as a platform thread, right? Means key operating system thread. So whenever you are writing code using this synchronized keyword, and in future we are going to understand one is the JVM thread, not the platform thread, not the OS thread. There is a concept you can create thread bar from the JVM side itself. That is
अच्छा.
known as a virtual thread. So whenever we are going to virtual thread always suggests you can use the lock interface so that you can get the major benefit of virtual thread. If you are using the synchronized keyword, you have get some problem. Whenever we talk about the virtual thread, I am going what is the detailed problem. Until till today, you cannot understand what I am going to say if until we not complete the virtual thread concept, right?
Mhm.
So just FYI, virtual thread is not work for synchronize.
Mhm. Yeah.
Is not work on unsynchronized lock. Unsynchronized lock. This is
Yeah.
the some kind of a drawback or something. Benefits. Generally, Java as a language suggests, if possible, you can use this lock interface because this lock interface implemented by as a Java language. And this
Mhm.
synchronized keyword is implemented by your operating systems.
अच्छा, 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 अच्छा.
So this is complete control taken by your operating system. If I'm running on a Windows machine, the OS is responsible to uh, saying hey thread wait, hey thread release, right?
Mhm.
But in the case of lock interface, this is completely written by the Java language in the Java JVM itself. But now JVM control your code. Hey, wait, notify, release, try out. Due to that, they have given option try out, try lock, timeout, right?
Mhm. Mhm.
So due to that, Java as a designer just suggest, if possible, you want to getting the lock of an object, try to use this lock interface,
Mhm. Mhm.
right?
Right.
But both are the similar things. Basic objective of your synchronized or lock is you are going to ensure if this is the my code, this is the my room, at a time only one person can use them. Here only
Mhm.
one person means thread.
अच्छा, अच्छा,
Basic
अच्छा.
meaning of maybe lock or synchronize. Allow at a time only one person or thread going to use my room, या call my method, या execute my code. Okay. In the terms of multi-threading, this code, these sections known as a critical section, right? Are okay, and the operating system concept known as a mutex. This is the OS terminology, mutex. Mutex means this is the code where at a time only one thread can access or only one thread can read, right?
That's called muted.
Mutex.
Mutex.
These are different terminology of the alternative of synchronized. You can say synchronized, or you can say mutex, or you can say critical section, or you can say mutual exclusion. These are different word terminology are related to the same. If you study the operating system book, you are not finding the word like synchronized or lock. You can find the word like mutual exclusion or mutex. Right? But whenever we are talking about the Java programming language, we are talking synchronized, we are talking lock. Right? So now it makes some sense what the differences between the synchronized or lock interface as a keyword, as a interface. This is the interface and this is the keyword. Lock is an interface, yes, and synchronize is a keyword. Right? So it's okay.
Yeah. Thank you, everyone.
Any doubt, any question, any confusion? I am going to write these things here, right? Okay.
Excuse me.
So let's do practice. Any doubt, any confusion, we'll discuss. But same thing, almost for mutual exclusion or synchronize or lock, we have almost done three. Same example, producer consumer in a three different way. First, we have writing the same problem, producer and consumer problem, without using lock, right? Without using synchronize, without using your lock interface, just using the flag variable, right? And second, the same producer consumer problem, we have taken example using the synchronized keyword. And today, the same program will be written using the lock interface. Okay. And 1, 2, 3 more approach, we are going to understand the same problem, how different way we can implement, right? This problem, how I am going to producer consumer, easy to explain and easy to understand, right? It's good for the day.
Yeah, it is good for the day today. Yeah.
Any question, Riyad, Anish?
No, I'm fine.
Yeah, by far, this is more practice needed topics on Java.
Yeah. This is, you can say, one of the core complex things. And
Yeah,
complex. It is really complex. Yeah.
because here there is no any hard to programming. There is a hard to imagine the situation and scenario. Lots of hypothetical things we have to imagine. In this case, what happened? In this case, what happened? Before writing code, we have to think all the possible cases. What happen if thread come here, wait or notify, or what is there, right? Not the sequential execution of code, right?
yeah,
Might be they are doing some 2 steps and after that they are going to wait, and some another thread come doing something, again notify, right? So here lots of things you have as a developer, we have to think while writing code, not one sequential steps. We have to think possible cases, what happen on your system, right?
Sure.
Good. Yeah. So as of now, our intention, you have just understand the concept, so that if someone going to talk, you can easily relate what is happening, what is the meaning, right?
That's it.
Okay, great.
Yeah.
Let's practice. Any doubt, any confusion, we can again discuss it.
Sure.
thank you.
Thank you.
Thank you, everyone.